Hi, welcome. It is Serverless Office Hours Special Edition, and we're super excited. My name is Eric Johnson. I'm a principal developer advocate here for Serverless at AWS. Talia, tell them who you are.
I'm Talia. I'm a senior dev advocate for AWS Serverless, and I'm joined here with Jeff. Jeff, do you want to introduce yourself?
Sure. I'm Jeff Barr. I'm VP and Chief Evangelist for AWS.
Great. So we have a packed schedule today. We are going to start off with SQS story time with Jeff.
That's right.
And then
I'm excited about that. I'm not going to lie.
And then we're going to hear from some of our serverless heroes. And then we'll have time for some Q&A where we can answer your questions. So when we do that, feel free to post them in the chat. And finally, we're going to have some birthday cake.
That's right. So I'm going to interrupt here really quick because we said we have a special show here, but do you know what it is? The special show is the happy 15th birthday for Amazon SQS. This is a special event. 15 years ago, I believe today, right, Jeff?
Today.
Literally today, 15 years ago, they actually released Amazon SQS. And so we're going to jump into, you were there.
I was there.
Were you like in the room pushing the button?
There wasn't any one room, and
okay.
there wasn't a room. I don't remember the button.
Okay.
I don't remember it as like being an actually momentous event.
Okay.
It was
kind of a.
It was really low key.
Yeah.
It was really low key.
All right. So let me ask you this. All right. So the SQS launch was really part of the AWS launch, right? So it was kind of one of the, and I know there's some debate on that. One of the first services that came out and said. So can you tell us what it was like when you were there? Did you have to explain the web service?
Oh, I had to explain everything. And
okay.
Back in the beginning, there was this protocol debate that was all-consuming, and it used to be the SOAP versus REST debate. And we used to share all these statistics of how many people are using SOAP and how many people are using REST, and they wouldn't actually focus on these are the cool services. It was like, what protocol are they using to get to the services, which was kind of interesting, but a little bit frustrating. But it was really cool just to be able to share these really early details of these services and just say, well, this is what it is and this is what it does. And we really didn't put on any airs about these services. It was more about just being very factual, very direct, as technical as we could, not layering on too much marketing, too many adjectives, too many superlatives. We're just like, this is a cool thing, and if you're a developer, take a look at this, and maybe you'll find it useful.
Do you still have to convince people to use queues now?
I think most people get it, but it's always worth re-explaining, and you have to remember that we have some users that have probably been using this since the very beginning, but there's new developers being minted every day, and you have to make sure that they feel included and that they don't somehow step up and say, oh, I'm 15 years too late and nobody told me about all these good things. So it's always worth re-explaining what we have.
So is that so let's go back for a minute. You were talking about it was a very kind of a quiet. Was there a purpose behind that?
So I think we've got this principle at Amazon of being willing to be misunderstood for long periods of time, if necessary. And
that's why I work here.
We never ever tried to. We'll never misdirect anybody. But sometimes we'll have a big vision. We'll have a roadmap. We'll be thinking for the long term what we want to do. But we don't always think that it's necessary to share that. Sometimes it's better to simply put these things out there and let the people in the know kind of figure it out for themselves. And maybe put a couple data points out there. Let them actually see the trend, see the pattern. And I for sure remember when we put SQS out there that some people said, why would bookstores sell message queues? That is like a negative amount of sense. This makes no sense whatsoever, but that's okay. We're okay that it didn't make sense to everybody. But a few people said, distributed applications, loosely coupled, asynchronous messaging. I know exactly what that's for. I see what's going on here. I'm going to go ahead and make use of that.
So I want to ask you a question about that, but real quick, I want to point this out. If you look on screen, there are two other screens here where, hey, I'm going to wave at them. This is our SQS team. Hello, SQS team. Yay! And these are the folks behind the magic. We get to get up and talk about it. We have a cool job. We get to get up and talk about it, sometimes take credit for it. You may not do that. You're more professional than I am. But these are the folks that build this and make this magic work. So, big
Big thank you.
I'm going to give you a thumbs up. Theoretically, so you got it. All right, so so just wanted to say thank you for joining us. They're going to be with us for a little bit now, and then they're going to, when we bring on our heroes, we're going to drop off, and then they're going to come back for the cake cutting. So super excited about that. Now, Jeff, earlier you were telling me a story about someone who wrote the book on queuing. Tell me about that.
Okay, so my friend Doug Kay, he had written this book called Loosely Coupled, and way before SQS was a thing, he had written this book. I think Doug had this background in mainframe IT, but he understood loosely coupled distributed systems. He understood the ease with which you could have all these separate parts, and you could connect them together with message queues, and that you could do something that was very very flexible and could scale very easily. And Doug saw SQS, and he was working on this really cool thing, this company called Gigavox Media. Oh, there's our architecture right there on the screen.
Yeah.
So Doug had this company called Gigavox Media, and he was super early in the podcast production space. And Doug looked at the three services we had back then. He looked at S3 and EC2 and SQS, and he said, I'm going to build a podcast production system around this. And he made it highly scalable with SQS. You can see there's several queues there on his diagram. And what his system did is he'd have the podcast authors would upload basically the raw podcast, kind of the guts of the podcast. And then his system would go and it would add the intro, it would add some ad inserts, it would put some breaks, it would put the outro, all the ad insertion dynamically, and generate one nice, automatically, smoothly leveled podcast as a result. Doug actually had a background as an audio engineer, so he was really particular about sound quality and made sure that the levels were consistent across the entire podcast, across the entire series of podcasts. But Doug, having written this book called Loosely Coupled, looked at SQS and said, this is exactly the thing I need to implement this architecture. And I remember him emailing me in the early days, and I found this email last week, and he said, I built this and I used every AWS service, which
How
great
many
for
were
the time.
there? 3?
All 3.
Yeah.
This was
Try doing that now, Doug.
Yeah.
Well, this was before even EBS. This was when EC2 had only the temporary storage.
Yeah.
So it was EC2, SQS, and what was the
And
other
S3.
one? S3. Wow.
Yeah. I go back that
We've come a
far.
long way.
Believe it or not. Yeah, my first account does not have a VPC in it. So yeah, that's really cool. And as you can see that we had the architecture up there showing that. Very cool, very cool. So let me ask you this, and I'm gonna steal your thunder for a minute, but I want to know, what was your first SQS project?
So I tried to actually go back and find the code, which I couldn't because I wasn't good at keeping stuff back in the early days.
You ever heard of Git repos?
This was before Git.
Okay,
No,
all
this
right,
was
just
before
checking.
Git
It's
repos.
Mercurial and SVN, yeah.
My source code control time dates back to this thing called CVS.
Wow.
Yeah, and I still got stuff in CVS. Anyway, I'm sure I wrote a demo app for the blog post. I cannot seem to find it, and I didn't actually put any code in that post, but I'm pretty sure I wrote something to put some things in a queue and take them back out.
So that was your first, just putting stuff in and taking it out and stuff?
I'm used to be dev, so I can't actually build things that are useful anymore. But I can.
That's all right. But you talk about them. You're very technical.
I can pretend, but I will always admit when I'm pretending.
Yeah, there you go. There you go. So yeah, I understand that. All right. So yeah.
When SQS launched, did you anticipate that it would grow to be as big as it is today? Did you think that it would be continuously like this?
It was really clear we were doing something important, but you never get the sense of history until it's actually happened. Like you can imagine other companies might want to say, well, we're now getting into this brand new era of cloud computing, and you're on the stage and there's like smoke or dry ice or whatever, and lasers, and it's like, we're about to usher in the brand new era, and here's message queue. Yeah, exactly.
Yeah,
and with your drums.
Right?
And that's the way some people choose to launch, and that's okay. We don't tend to do things. We're kind of more quiet. It's okay, here's a thing. Here's what it is, here's what it does. Yeah. Let's just let customers figure this out for themselves. And so I don't remember the SQS launch is like, whoa, we're now embarking on this amazing journey that'll get us to like where we are today and like these tens of millions of requests a second and all this awesome stuff. It was like, here's a simple thing, we're gonna do it really well. We'll put it out there for devs and they'll find it and do awesome stuff. But it wasn't like, kind of like this like NASA style launch of like, okay, countdown and now cloud computing is in action. It was a lot quieter than that, and a lot more.
I mean, I'm sure the team and everyone knows that, they're really proud now that it's lasted this long and it's continuing to bring a lot of value.
Yeah, the longevity is
Not
huge.
just bring value, but we still continue to make it better.
Exactly.
And we make it better from the API level, and the team can probably tell us better than I can, but I'm sure that they continue to profile and optimize and figure out ways to make it even more efficient and more reliable internally. The things that customers benefit from that we don't necessarily even have to tell them about.
Yeah, in fact, you wrote a blog on this, and you may be talking about this later, but you wrote a blog where you talked through it, and we've got it on the background, and I know they bring it to the front a little bit, but every year it is a series of functionality that's being added and it's kind of fun because it's like, I never thought of that. I was one of those when the Q came, and you know this isn't the Eric Johnson story, but going back when this first came out, I was one of those that went, I don't know what that is. I don't understand that. Now, I consider myself a speaker who develops, not really a developer. You know, I'm technical, but I'm not incredibly technical. But I remember looking and thinking, well, why would I use that? But then I got to understand the idea of queuing and throttling and understanding this, getting events going, and I was blown away. But then you kind of get in your head, you're like, well, there's nothing else they can do. But that's not true, is it? Every year, and as we go through these, in 2009, we went out to Europe and added the ability to add permission or remove permission. This was kind of a big one. Can you talk on this for a minute?
Yeah, this was a big deal because we made SQS available in Europe because we went from a single region to several regions, and then giving customers control of exactly how the queues could be accessed, that's a big deal. And that access policy language has evolved into IAM, which is, that's something we launched in 2009 as kind of a important aspect of one service, is now really central to really knowing how to get good, safe use out of it, all of AWS.
Right,
That's
it's really the foundation of using all the services.
Security. Have you all heard of IAM? Yeah, it's fairly. It's a big deal.
It's the new big thing.
Yes, it's a new thing. We just came up with it right here. Not trying to take credit, but we did. So no, honestly, that's so foundational to security, as Talia was saying, so foundational to security of what's going on. I didn't realize that it started at SQS.
Honestly, it wasn't until I went back and read that I said, oh, that was the beginning. Sometimes these things kind of sneak up on you, and there isn't always this momentous announcement. It's like we did something, it solved the problem, it worked really well. I'm sure the next team came along and said, okay, we've already invented this, and let's continue to generalize it. We're not going to reinvent the wheel. Let's make it so that the learning the customer does that first time actually applies across multiple services.
Yeah. See, I would have been cooler if you just said, honestly, when we went back and I looked at that, I told them to use that everywhere.
It's so easy to look back on history and think, okay, it looked like this very, very well disciplined, and that you had this long-term vision of the future. But honestly, it's a lot of good decisions, just day by day, step by step.
And then in taking that, and I don't want us to go down a rabbit hole, but taking that in kind of, it's really interesting how Amazon will take it and say, that worked. Let's not reinvent it. Let's take that and apply it across. That's where S3 came from, right? That storage works. Let's quit reinventing that wheel. That messaging works, SQS and IAM. So that's pretty awesome. So. All right, so here's an interesting thing. So some SQS feature launches had been highly anticipated, right? And you know the one I'm going for here. So it's Lambda, right? So when we came, SQS, originally you would poll it, but then you could make it where SQS would trigger or invoke a Lambda function. I almost said lambdas, and Chris would actually, he's in the room, I think he will tackle me. He's giving me dirty looks right now. But I'm on screen, I'm not afraid. So, but when it could invoke a lambda function, how did that change things?
I think that was a really big deal, because that connected up, literally connected your message queue up to your code, but I think that event-driven model was a big step forward for Lambda, and showing customers, okay, these messages are coming in, and do some processing, and then quite often you're just dropping the message into another queue, and you can build these really nice multi-stage pipelines of like, do one thing really, really well at your own speed, at your own scale, finish it, pass it along to the next stage, and have all these nice little parts that just do their own thing really, really well.
Yeah, SQS, if we could define it a bunch of different ways, but SQS is the essential of decoupling, right? It is the essential underpinning to breaking that apart. And then, of course, SNS is pub sub. And
I think the line I used in my blog post today, and it's not my line, it was one of our teammates, they said that SQS is basically the lines on your architecture diagram.
Yes.
Yeah.
That's great. Yes,
it's not my phrase. I will not take any credit for it.
I will next time I talk. So, so excellent, very cool. All right, so we got a couple more questions we wanted to ask you, if that's all right. So,
so what do you think is going to be coming in for SQS in the future? Like, what do you wish to see in the future with SQS?
Man. So, I wish I was enough of a dev to have like a really deep answer, but I think going through that entire list I put together for my blog post I published today, I think we've been very careful just to, we kept the simple there, and you could easily figure out a lot of ways to add a ton of complexity to it. I think we've added a lot of extra control and lots of options, but they are options. Like the creating queues, putting stuff in queues, taking stuff out of queues, deleting them, and listing them. That's really all you need. And you can do amazing things just with that set of simple operations. So a lot of what we've done is kind of just to add things that are effectively optional, that are really helpful and give you new use cases, but they're not things you have to master before you can get any value from the queue. So what I would hope is that we never forget that simple part. As far as a specific thing, I'm not enough of a dev to know what, but we have, in Amazon tradition, we need customers to tell us that.
Yeah. Right. And you are right. We have this queuing service, and it does queues really well, and as long as it continues to do that, we'll be in good shape.
And the funny thing is, simplicity is so difficult. If you're not a designer of things, it's easy to think that, well,
that's a deep, and I'm not making fun of you, that's a deep statement. Really, it is.
But when you talk to people who are not designers, they think that you start with nothing, and the first iteration from nothing is simple. Yes. But usually you start from nothing, you invent a whole lot of really complicated stuff, and then only through a lot of insight and experience can you actually narrow it down to what is truly simple and what's that kernel of what you actually really, really need. So getting to simple and staying simple that's I think the real magic of what we get to do here.
You know, it's funny, I was just having a conversation with a developer who had reached out to me and said, this is so hard, you try to figure it out. That's a really good statement. Simplicity is complex. For us as AWS to make it simple for you, that's complex. There's so much going on underneath to make that happen, and I love that. And that's a
and
great
it's also worth noting, because this was a lot of confusion in the early days when people saw simple queue or simple storage. They pretty much thought we invented it on a Friday, implemented it on a weekend, and launched it on a Monday. Yeah. It was not simple to implement. It was keeping that API and the conceptual model really simple was what we really had to work for.
Yeah.
We also have, I'm going to put a plug here for our serverless land site. We have a bunch of patterns that use SQS, so if you're struggling to set up SQS with one of the different services, go to serverlessland.com and you can check out our patterns.
Yeah, definitely. One more thing I wanted to chat about, and then we're going to talk to our service heroes, but one of the interesting things is how other services are tying into SQS now. For instance, earlier last year, we released HTTP API direct integration with SQS. And so the ability to say, because it used to be, okay, I'd connect to a Lambda, and then I'd put something on the queue, or I'd connect to the API, but I can directly drop stuff on a queue. And so services, and we use SQS internally quite a bit, don't we?
We sure do.
Yeah. So a lot of the services,
we should share some metrics about that, actually.
Say again?
We should share metrics about that.
We should, yeah. So, well, with that, I think we're going to, we're going to bring on Farah.
Perfect.
Farah Campbell, come on up. She's pretty excited.
So Farah works with our serverless heroes, and I think she's going to intro our heroes for us. Farah, come on up.
That's right.
So I was trying to hear.
Yeah.
Front and center.
Yeah.
All right. Well, I'd love to welcome the heroes on. I don't know if they've joined us yet. Are they with us yet?
We'll see them up here on screen. We're waiting for them. Who's coming? Who's joining us?
Well, we have Sheen Bristles joining us all the way from London. We have Ken Collins from Custom Ink, and we have Jeremy Daly, who just recently joined Serverless Framework. Thank you all for joining us.
Thank you for joining us.
Everyone.
Yeah.
Thanks for having us.
So the heroes were, I used to be a serverless hero, so this is different. I'm on the other side now, so it's kind of fun to be able to come and chat with you all here. But I did reach out as part of the celebration to ask them what their favorite use case was when they first used it. Jeremy was the first one to respond within 2010, I think you said, Jeremy, and used it as a lightweight throttle queue. What else can you tell us about that project? Do you remember details about that project from 2010?
No, anything from back then I try to put out of my mind because it's just everything has changed so much. But I remember for that project, we actually built a custom facial recognition software. But in order it was so slow to process it that if too many people uploaded images too quickly, then the thing would just die. So we stumbled across SQS and we saw oh, whoa, hold on, we can actually sort of throttle this but not lose the actual request to do it, and it worked perfectly. So it was a little bit janky and a lot of popsicle sticks and duct tape originally, but we got it to work and it was awesome. Not SQS, it was the software that we built. So it was amazing, and since then it's gotten so much better that I don't know how I'd build an application without it right now.
I think I heard a number of heroes stating the same thing. I know that Ken, that you're using it actively as part of an active job, and well, we know you love Rails at Custom Ink. What are you hoping to see next with SQS, and what's been your favorite feature so far?
Well, I think the obvious answer is what Jeff said. It's going to need some dry ice and lasers. But besides that, I would probably go with better error handling. And just for context of that, we're sort of leveraging Rails inside of Lambda. And when you do that, we're taking a huge advantage of the sort of built-in polling that SQS can deliver to these Lambda functions. And I certainly believe that the future is going to be where this not only managed services, but this managed polling is going to be a big part of how we engineer things. What happens with that is that when you get that polling in place, your only mechanism for dealing back with it is to kind of send it an error back, right? Like, and it's very classical in Rails jobs to do errors and retries, and we have this sort of exponential back off. So I think what would really help is being able to have this sort of nice communication mechanism, either for one job or n number of jobs of a batch, to be able to say that these ones were successful and these ones we're putting back in. And the favorite feature with that is, of course, the visibility timeout, and that's how we can get that exponential back off and that retry logic.
And Shane, I think you said you first used it as an experiment to prove how efficient how efficient serverless was for your data transformation pipelines. I'm assuming that it proved to be very efficient.
Yes, exactly. Yes, so SQS wasn't the first service, it was the third after S3 and Lambda functions. So we wanted to experiment that simple data pipeline as our entry to serverless. So the problem was that we thought, okay, you know, files get dropped into S3, Lambda function comes on, cold start, etc., before it hits the commerce platform, which is a SaaS platform. But to our surprise, it was moving so fast, and we had problems. You know, we were hitting so hard the other platform over there. So we wanted to slow things down a bit. So that's when we realized, oh, SQS can act as a sort of the buffer, you know, between the Lambda functions and the other platform. So that's how we got into SQS. But then we realized that it's just, you know, more than a queue. There are many features we could make use of. So then we started to look at splitting the Lambda function into doing transformation on one side and dealing with the third-party platform on the other end, because SQ is able to provide us the redrive and the DLQ mechanism. And also, we had queues that wanted to be processed faster, and other, you know, queues wanted to be slower. So we were able to make use of the, you know, the long polling, short polling, and also the delay attributes and other things. So it really kind of, you know, paid off for us with that sort of data pipeline. So we kind of started with 3 different feeds pipelines. Now we have over 20, and similar mechanism we use in other places as well. For example, we have the simple email service where we dispatch, you know, thousands of emails. So we put a number of queues before so that we can prioritize, you know, the sort of the priority emails from the, you know, the lazy ones, and that way. So it's so there in everywhere, especially when we decouple services and things. Yeah.
That's awesome. So what advice would each of you have, and maybe we can start with you, Jeremy, you know, what advice would you have to builders that, you know, SQS is highly scalable with few limits? You know, what advice would you give to them to make sure that those workers stay scalable?
Yeah, I mean, I think the big thing for me, which I quickly realized, I mean, I was a very early adopter of Lambda. So when I first started building things, it was like, hey, Lambda scales really, really well, but all of these other services I'm connecting to, they don't. And so this idea of putting SQS in between all those different things just made so much sense because, again, not everything is as scalable as you would hope it to be, whether it's an API that you're hitting downstream, or in my case, it was hitting a MySQL database. You sort of kept on it would fail on the writes. So this idea of being able to sort of take this input directly from the user and quickly sort of buffer it and then slowly work through that queue, that adds a tremendous amount of resiliency to your applications. And I know, Eric's a big fan of this storage first pattern. As soon as I discovered the ability to go right from API gateway directly into SQS, I started using that for every single webhook, pretty much anything that would have some sort of spiky traffic, because it's such a lightweight transaction, but it captures that entire message. And then you can go ahead and throttle that as you process it downstream. So I would say if you're thinking about building an application and you need to connect to services, especially if it's synchronous initially, you want to take that and you want to put an SQS queue in between there, because that just is one of those things that, hey, the database went down. The database could go down for hours. My queue will back itself up, but eventually it's going to work through that process. And so that amount of resiliency that's added to an application, that architecture to me is like, I don't think I would build anything without that in place, because I would fear losing those messages. And of course, with dead letter queues and all the other great things that SQS has built into it, there's just so many layers there that, allow you to take your application to a level that was, so hard to do, back in the day, however we want to classify that. I'm pretty old, but anyways.
Yeah, and it works well, like you said, when when services are down, but also when you have really high traffic for one part of your app. So, yeah.
Absolutely.
Ken, anything to add to any advice that you would give?
Ken or Sheen?
Ken.
Okay. Yeah, I think I'm right on board with Jeremy. I've never been able to do that sort of advanced pattern before. I love that idea. But for us, it would go back to that visibility timeout, right? Like, I really like how that sort of redrives that logic or that error handling at a time that we choose, and then being able to sort of like re-queue that message and let SQS sort of take sort of charge of when to bring that back to your function or other handlers would be sort of really great, right? Because that will allow the engineers to sort of take that back and say, like, when I need this back or how long I should defer this work.
So I'd be curious to ask, Sheena, I just totally jumped in front of you. I apologize, but I'm going to keep talking. So I did want to ask, and Sheena, if you want to jump on the same thing, but talking about the patterns you both did, in addition to just, so we talked about the error handling things, but it reduces code too, doesn't it? When we think about get that storage first, if we're moving a lot of that error handling into SQS and we're handling the DLQs and we're bringing those back, one of the things, and this is where that storage first pattern came from, because I've often said, the most brittle part of an application is Eric Johnson's code. So, but one of the things is if I can roll off the routing, the error handling, and all the things that I tend to reinvent that wheel in a Lambda function, it reduces code and it adds stability, and yeah, that's why I love that pattern. And Sheen, I deeply apologize. I want to be quiet and you talk now. So.
No worries, don't worry.
All right, Sheen. So go ahead. What recommendations would you have for everybody?
Yeah. I mean, one main thing, if I may say, is if you are building resilient applications, think of SQS, because it plays a crucial role in performing as a, sort of the DLQ backup mechanism, especially when we, build circuit breaker patterns and things like that. SQS is always there, and it's something that, we can't, live without. Yeah, I mean, I know that there are other services now can replace or fill in the part, but SQS has its own place, I would say.
Can you define? And I hear it all the time, and I think some folks may not know what it is. I know. I'm sure I know. What is a circuit breaker pattern?
I will leave it to Jeremy, because Jeremy is the one who wrote about it first.
Yeah, well, I didn't write about it first. I think it was Tim Bray was where I read it from. But the idea of the circuit breaker pattern is if you're connecting to a third-party service, the worst thing you can do when you're sending traffic to some other system is if it starts to respond slowly or it starts to degrade, for you to keep sending more work to it, right? That's sort of not a great net citizen sort of thing to do. So instead, what you do is you say, hey, if this starts to fail, I'm going to go ahead and I'm going to, flag some piece of state somewhere, and I'm going to say, I'm going to go ahead and open the circuit, meaning that rather than sending traffic there, I'm going to either bounce it back, maybe I'll queue it in an SQS queue, for example, but I'm basically going to stop sending traffic to this downstream service. And then every once in a while, I'll check it. I'll do what's called a half open, and I'll check to see if that service is responding. If it's not responding, then no problem. I just keep on queuing my requests or failing back to the user. But then if one of those requests, those half open requests succeeds, Then I can go ahead and close my circuit, like electricity can flow through it, close the circuit and start sending the traffic again and start working down my queue or however I back that up. So the idea of being able to necessarily, and again, it depends if you want to queue that or maybe you want to fail back directly to the user, but it's a way for you to sort of mitigate the pressure to downstream services. And it also just works really well just to make sure that, against your own systems where your own systems might have limits. So even if you're communicating inter-service or whatever, you may want to make sure that you implement that type of pattern as well.
All right, thank you. I appreciate that. Before we jump on, I do want to say we're going to be answering, in about 10 minutes, we're going to be answering some Q&A. Open it up to answer your questions. I see Chris and team are answering questions in here already. Chris says, apologize for me. I'm not sure why, but I apologize too, I guess. So, yeah, so start dumping your questions in. We have some experts in the room, and I'm here. And we can answer questions as best we can. So,
are we seeing any questions already?
We're going to answer questions in about a few, but I want to start getting some coming in. So, back to you. I'll let you.
Gotcha.
Yeah.
All right. So I'd like to hear from you guys. What's your favorite use case for SQS? I know I asked this before, but it seemed like the differences were, they were all different. So I'd love to hear from you guys. What's your favorite use case? Sheen, we'll start with you this time.
I must say the data pipeline, because I think Eric and Jeff mentioned earlier. So you can even take it to along the lines and have that split in place and have something, as I mentioned earlier, transform something, push it to the queue, and get a Lambda function to process and dispatch to somewhere else, and that really works well. And also the best thing I like about it is the ability to adjust the queues according to the use case. So,
Ken?
Well, we'll go back to doing jobs, right? Like, I think it's such a huge part of the Rails ecosystem to take every bit of the request and the response and just get back that HTML or that server response to somebody as fast as possible. So it's just really built in our DNA for years and years and years that anything that does not need to happen within that request response loop should happen on a background process. And SQS just does that really well. We no longer need to spin up a Redis instance on EC2 or even use a managed Redis instance. We just use SQS, we use the redrive policy, we set the logic, and just let it go and do the work and hook it right up to our same Rails process that does the web application, that also has the context and the database connections to do the work that you asked it to do in the first place.
I'm really enjoying all the different setups that we've seen in the background. I keep looking at the mural in the back.
Yeah,
it's like catching my eye. So, and Jeremy, what about your favorite use case?
Yeah, I mean, I still love that storage first pattern, that idea of, any incoming webhooks, being able to capture those quickly and not having to expose it to Eric's code that might fail and not get it, not get it into the database or whatever. I love that. But then, the funny thing is here we are 15 years later for SQS, and it's been a huge piece of the system that I've used in order to do the throttling to downstream services. But as AWS continues to evolve, there's a new kid on the block, Event Bridge, that has that API destinations built in now, that sort of is taking away from the that little bit of shine that was on SQS for that particular use case. So that has been a very popular use case for me for the throttling. But I've been experimenting with the API destinations, and it might beat out SQS on that.
Interesting. See a battle going on. No, it's a great service. Yeah, very cool.
All right, heroes, do you guys have any questions? I mean, I'm gonna put Eric and Jeff and Talia on the spot. Do you have any, since we have them all here, do you guys have any questions for
I see Jeremy's eye. He wants to stump me right now.
Well, you are our customers.
Yeah.
Let us, and this goes all of our customers, always let us know what we need to be doing different, better, and so forth, so we can keep on making SQS even more awesome for you.
Yeah, I mean, one of the things that I would love to see is a little bit more control over prioritization. I've experimented with using like Fifo queues and the message group IDs and some of these things in order to try to classify a priority, so certain things would get processed sooner rather than later. But it would be really great if we could take just a standard queue and add priorities to those that would somehow add weighting. So for the ones that weren't ordered, that it might be able to pull those high priority messages out first.
So to expand, and I know you're the hero, we can expand a little bit, but FIFO queues, what are they? For people who may not know.
Yeah, first in, first out. So you can do ordered queues. So if you're using something like Kinesis, for example, Kinesis is always an ordered stream. Whatever you put in first is the first thing you're going to get out. SQS added this, I think it was maybe 2019, 2018. SQS added ordered queues, but in order for you to process larger batches or multiple streams, you could use a message group ID, and you could actually almost pretty much shard an SQS queue into multiple shards, and then you could process lambdas off of that. And so you can do that, and you can use that as a way to do ordered priority by using a message group ID with a higher concurrency limit on the lambda that processes that particular message group ID, but it's not the best solution there. So it would just be really nice to have that ability to do, to just say like this is a priority 1 or this is a priority 100, and then if it starts backing up, being able to pull those out. It doesn't have to be perfect, but there has to be some sort of priority that gains, that those messages get elevated.
All right. I know. Were you gonna say something?
Yeah. So Sheen, you actually used the phrase. You said priority queues and then lazy queues. So is that anywhere close to what we just heard?
Yeah, exactly. So what I meant was, adjusting with the polling intervals. So that's something would be useful to have more control on that.
All right.
So we've got 2 data points now.
Excellent. Yeah, and I know that, like I said, our SQS team is listening and watching. We'll be back on a little bit later, and they're madly writing things down too. So, yeah, definite feedback. Ken, what about you?
I think I'll go back to the visibility timeout one again, but I wanted to at least sort of stress the meta aspect of your question, and that is that indeed, I think everybody that is an AWS customer should always think of AWS as an extended part of their engineering team. You'll do a really great job of listening. You want to help us out. You want to make the product better. You want to find those use cases. And I've always appreciated the time, whether it be for heroes or just anybody in an organization reaching out and talking to y'all. So thank you for that.
Yeah, that's Talia and I, that's our role. Well, all of us, we all do that for sure. But as developer advocates, it's a two-way thing. And so we want to hear. And sometimes, we may not know the answers. This is what I always tell. I may not know all the answers, but I know the folks who do. I call Jeff directly, and he knows all the answers.
I just Google stuff.
There you go. So, good job. That was very circular. So, but yeah, I appreciate that plug, Ken, very much so. And so we've got a couple of questions coming in. Did you have another question you want to ask the heroes?
No,
okay, all right. So we've got a couple of questions coming in, and we're not going to throw our heroes out just a minute, but we are going to trade some folks out. But we had some questions coming in. Let's see if we can answer here. So, and I may let the heroes help me answer these if they want to. So, what's the best real-world how you doing, Eric? What's the best? They pay me to speak here. Y'all get that? What's the best real-world scenario to choose standard SQS or Fifo SQS in terms of cost, message delivery, and performance? And Jeremy, I'm going to ask you if you want to take a whack at that, just simply because I know you deal with that a lot. What are your thoughts?
Yeah, I mean, it has to do with if the ordering of those messages is important to your process. So if it is something where you're doing database capture, you're capturing database changes, for example, it'd be pretty important for you to know that a delete came after an insert, something like that. So having anything like that requires that sequential processing of messages, I think is super important. If it's something like, even if it was, clicking the like button and having that update a database or do some processing or something like that, then the order in which those come in probably isn't that important. But I mean, in terms of the throughput of it, if you have a queue that has, that isn't ordered, I mean, the throughput is massive. I mean, you can have, thousands of lambdas processing off of this thing and being able to read these messages very, very quickly for you. If you go with the ordered route, then you have the problem of essentially having to shard that, using that message group ID and being able, you still scale out, but you scale out to the limit of, I believe, the number of message group IDs, the cardinality there for that. And so that can slow down that throughput. The other thing about Fifo queues is poison pills. So if you have a bad message in there and that's causing things not to process correctly, There's some more controls with that now. Kinesis has a lot of great controls for the the bisecting, and now it has the, forget what it's called, but basically the iterator ID where you can find the exact message that's trash and get rid of it. So you do have that problem as well. Whereas if you're processing things from a larger queue and the order doesn't matter, poison pills really don't necessarily matter because they might keep coming back up, but you'll still be able to process other messages behind it.
All right,
Nice.
yeah.
I have a question. What were you going to say?
No, go ahead.
So when people start to use SQS, it sounds like most people implement them reactively as opposed to proactively. Like something went wrong, like they didn't have a queue, so now they realize like you need a queue.
Yeah.
Is that, have you noticed that's the way that people usually start to use SQS?
Yeah, do you want to?
So I think it's a really good question, and I think probably a lot of folks at this point do understand the whole idea of having a bunch of little independent functions and connecting up with queues. But there's another set that kind of come in kind of more from the fixed processing side. It's like, okay, I've got the server, and the server does this thing, and they can only scale up to a certain point, and they say, oh, well, this part's just going too fast, and this one got stuck, and this piece is running slow. And then suddenly I think when you say, okay, you need to decouple all these pieces, and we've got this great thing called a queue you put in between them. Then it's like, oh wow, that was the thing I needed that I never actually knew even existed. And then you kind of give them that power and say, okay, you start chopping your function up into a bunch of pieces.
Yeah.
And kind of show them how it can be done a much better way, much more scalable and reliable and so forth.
And that's what that's pretty much your story, Jeremy, is what you said. It's like, we needed this, how do we throttle that, how do what? Oh, look at this, The other action is I think folks realize that they can do, hey, we could be doing a lot of this in batch. And so with queuing as well, as I don't have to do it one at a time, I can do 10 at a time, or I can control that. So maybe making better use of a Lambda function or the back end, whatever you're doing, they realize that. But I think it's a, didn't know this existed, but once you learn it existed. I mean, we see that with a lot of our services and understanding the difference between like pub sub, like SNS. And to throw back to what our heroes were talking about, especially with Fifo, another nice thing about Fifo is it ties nicely in with SNS as well. So when you're passing that, you can fan that out, and there's a lot of control over order. But I echo Jeremy's point in saying, is it important? Don't just do it for the fun of it. If you don't need order, don't do order. You know what I mean? Order is we need to have order, right? So, but again, touching on what you were talking about. So, all right, I'm gonna look here, see if if you have another question, or
No, I'm good for now.
All righty. We had another one that says, how can you use SQS to buffer transactions, such as make an order and you don't want to hit the DB directly, or you want to be up if the DB is down? How can I respond to users that their item has been cached or that there is no order number yet?
Look at me.
Yeah, I don't have to, or I can jump with that.
I've never built that app.
Okay. Sheen or Ken, you want to run with that?
I'm having a hard time thinking about the use case there, especially with the database where you don't have a primary key, but yet you want to create a job for it or some sort of like a message with, without that. I'd have to hear a little bit more on that. But I will back up what Talia was asking, that it is really easy for engineers to think of SQS later when you're doing work. And I think to Jeremy's credit, right, he's thinking about it all the time up front when work is happening beforehand. We had to do a type of work or a unit where we needed to migrate all of our product images, and we had Lambda functions that would do those, and we naively went and processed all that work by just invoking the function and letting it sort of build up. And the correct thing would have been to send those to a queue first and then let that invoke the function for you. So just to go back to the previous question, yes, always try to think of something like SQS first and putting that in front of your work.
Yeah. This in this question here, it says, how can you use SQS to buffer? I'm going to read it again so we kind of wrap our head around it. Such as make an order and don't want to hit the DB directly, or want to be up if the DB is down. SQS would be great for this. I think where we're at is, how do we let the customer know if it's still just sitting in the queue? And I'm running that through my mind as well. But one of the things you could also do, again, and I know we're doing happy 15th birthday SQS, but a lot of times it's right tool for the right job, right? And so something like that where I needed hey, this worked, that's great, or it didn't, I could also use a state machine or a step function to do that. And then I could drop it in a queue. So we could make one attempt to write to the database, it didn't work, then let's just drop it in a queue, we'll handle it later, and let the customer know, we got your data, we're good to go. And that's great for things like credit card processing, things like that, where we don't have to go back and go, hey, we lost your data, can you trust us one more time? So, so we're keeping that state, and so we could write that in. So sometimes putting together different services work great there as well. So right tool for the right job. And I'm open to any other ideas. Like anything else, there's a lot of different ways to do things. Jeremy, go ahead.
Yeah, and I was just going to say, I mean, this is the idea of eventual consistency, right? So this idea of getting a packet or a package of information, right? So maybe a JSON object, and maybe that has the customer ID, it has information about their order, the items that were in their cart. Like it could have a big sort of payload that has all kinds of information in it. And the idea of using SQS in front of the database for that is to say, I've captured the information I want to save in the database. So I know at a future time I can write this to the database, whether it's just slow or it's not up. So I can respond back to the user and simply say, hey, we've captured your order, storage first, right? And then say, you'll get an email when we process this order. And so then as your queues get worked through, and either it's Lambda or something else polling it, then you go ahead and you write that to the database. Even if that was to fail, right? You've got dead letter queues, you've got all kinds of alerts you could set up. You could respond back to the user saying, hey, it took us 10 hours to process your order, and this particular item is now out of stock. I know I've gotten an email like that from Amazon in the past, so I'm pretty sure that that's a fairly standard thing that you can do. But anyways, that's how you would do that. So you would basically just capture that. And in most cases, by the way, if everything is kind of going fast, you'll process that SQS message in, I don't know, a half a second, something like that, and that will be in the database. The message will come back to the user, no problem. But for that time where, something's happening with the database, or, there's something catastrophic that happens, you're still taking orders, even though, a massive piece, an important piece of your infrastructure is down, and that's resiliency. And again, that's the perfect use case for SQS.
Yeah, exactly. We have a similar use case on our side. So where we get orders from the customers, and then once completed, we push that to a queue, because our backend SAP systems are not fast enough. So we need to be careful before we package that, the order data and push to the SAP backend system. So there we have this, SQS playing the part, and also we have a, kind of a cache table in Dynamo that maintains the status of each order flowing through the pipeline.
And do you know how devastating it is if a kid loses their Lego order, if that message gets lost? And
exactly.
Nothing. Chris Munns, I've seen him crying on the
Chris
floor.
Munns, right?
So, I have a question for you. Maybe you know this. What was the first message sent over SQS? Don't disappoint me, Jeff.
I sure wish it said "Hello World."
Oh, that'd be awesome. I bet it
don't
did.
know.
Okay, all righty. It said "Hello World."
As far as we know.
Yeah, he said that's our guess.
There's
We're
no way to
not
verify, so
sure.
that's
Great
what we're
question
going
though.
with.
That was a great question.
If we'd only known, right? If you only know things at the beginning of history, you say this is momentous and you capture it. But sometimes you're just building a message queuing system.
yeah, exactly. All right, I'm going
at
to
world
see
scale.
if we have any other questions here. Our team has been answering a ton of them, so thank you very much. Do you all have any other questions for our heroes before we get rid of them?
I have just a comment, actually. So we have this interesting phrase around Amazon that originated with this guy named Jacob Levinon, and he used to say, there's no compression algorithm for experience. And it's been awesome to hear about your experience you've accumulated over your time with SQS. And I was kind of thinking, listening to all of you, we could have had parts of this conversation the day after the launch, because SQS fundamentally did most of the things we're talking about today. But your decades of accumulative experience have really given to at least to me, like this really interesting perspective on how to use it to its best advantage, and how the different aspects of it is really interesting. That just really points to me the value of what it means to actually have experience.
Yeah, the value of that, and you're right, there's no compression for that. So, Well, heroes, I wanted to say thank you very much. We are going to need to bring on our others, and so we're going to switch some folks out. I appreciate all of you. I've had a chance to sit and talk with all of you, and Fair, go ahead. It's hard to talk over. Yeah, go ahead.
Thank you guys for joining us. I'm so excited that you came.
Thank you.
Yes.
We'll see you all.
Thank you.
Should we get the cake?
Yeah, we're gonna get the cake out. So we'll get this out, and nobody's gonna sing happy birthday, but we are gonna cut this cake. But while we're doing this, I wanna ask you a question here. We have a stat up here that says in 2013, this is interesting. This is kind of an Amazon way. So support for larger payloads up to 256 kilobytes, right? And then the other main thing we did is we dropped the price by 50%. Thank you. I didn't even need to run with that one. Thank you.
Oh, nice.
We dropped the price. Now that happens with Amazon.
We do it all the time.
Yeah. How does that work?
We just drop the price, and then whatever part of the bill people are paying, they're going to pay. In this case, they're going to pay half as much as they were paying before, with no action on their part whatsoever.
Right. So we pass on the savings.
We do.
Right? So yeah, it's excellent. Now there's also thank you for doing that. I appreciate that. You know, I would have dropped that already. So.
Can we?
All right. Oh, that's gonna drop.
Do you
You're
see it in the
scared.
camera? No, it's not. It's stuck to the.
I
It's stuck to the
have
plate.
no confidence.
I
right
have
now.
a lot of cake
You're doing
experience.
great. Okay. All right.
Gravity's still working properly.
Having thumbs helps. So here's an interesting stat, and Tyler, you were talking about this earlier. What's the stat you were asking about?
Oh, yeah. So during Prime Day, Amazon SQS handles, or in 2021, our last Prime Day, SQS handled 47.7 million messages per second. Isn't that insane?
Just for Amazon Prime Day.
Right.
That was not all the other customer uses, though.
Yeah, and we didn't shut down everybody else to do it.
No.
So we kept everybody up and running.
Exactly.
Can you say that number one more time?
47.7 million messages per second.
It's crazy.
I don't know how to write it out.
Somebody needs to give SQS a break. Somebody needs to give SQS a break.
And then they slept for the night, so they were exhausted. But yeah, I mean, that's an amazing stat when you think about it, is how many, first of all, how busy Prime Day is, right?
Yeah.
And then how much data and events are coming in, 47.7 million per second. And I think, and it's really wise to point out, just for that.
Yeah.
Those, it's probably, I'm guessing it's more than one queue?
I have no idea. No idea.
It's 2 queues.
Yeah.
No, I don't know. I'm making that up. But yeah, this idea. So hey, look. Okay, our SQS team is back. Yay! Welcome back. We're so thrilled. Give us a wave again. All right.
So as impressive as that number is, any customer that has a similar use case, they can do the same, right? We didn't do anything special or magic or proprietary. Any customer can run at that scale.
Yeah, and I think that's we use our own services, and we use them just like customers do. So yeah, that's a really.
We usually say drinking our own champagne, but today we're kind of eating our own cake.
Eating our own cake. I always eat dog food.
Should I cut some? Do you guys want
Are we cutting now?
Are we cutting? Can we cut?
Yeah, let's cut. All right, and I'm not going to
Chef,
sing because they asked me not
I'm
to.
really bad at
Chris
that.
actually forbid it. So, but this is happy birthday. Welcome, happy birthday, SQS. We're very happy for you all. I like it. And I also want to take a moment to thank our interpreters who have done a fantastic job, who always do a fantastic job. They've been working with me. I'm not there yet, but we're getting there. So I'm going to go work for them. So. All right.
Looks like a really good cake.
You're like, no, what?
What?
No. You got it. All right. And they're cutting. Do you guys have your cakes out? I'm yelling like I don't have a mic on. Hey, can you hear me in Canada?
You got to yell all the way to Canada.
They're coming to us from Vancouver.
That's why I did this.
Wow, that was like the sloppiest cake. I mean, I love it. You're doing a great job, but I saw cake fly. I'm just saying.
Part of the experience.
They're way down the hallway. You got to yell even louder.
Thank you.
Yeah. All right. Yeah, they're down the hallway. So, do you guys have your cupcakes? They're passing them out. All right. We should have done the pre-cut.
I wish it would have when it flew.
No, you're doing a great
Okay,
job.
can I just say
I
when
think
it
you're doing
flew,
a
I
great
wish it
job.
would have hit you on the nose or
I'm
something.
trying to encourage you.
You're doing a great job, but your cake pieces look really bad, Talia.
Yeah. Wow. That was better.
No cake for you, Eric.
That was no cake. Yeah.
And you said you had experience.
That's right. Yeah. You did a great job.
Thank you.
All right. Do you want me to hold the cake down?
We're supposed to eat it?
I don't know. I've never eaten cake on camera before.
I never have either. I'm like, now I'm all self-conscious about eating on, but
I'm
you're
not.
fine.
I want cake. I will eat that.
I just want to put it on somebody, kind of.
I
Somebody's nose.
Eric, can I just put your face into the cake?
That's what I kind of
That'd
want
be
to
a
what I
first.
wanted to
Thank
do.
you. Thank you. All right, one more for
We should
you.
probably get Eric a fork too.
Oh, yeah.
No.
Ty didn't give me a fork. That's all right, whatever.
Sweet.
Thank you. Good. Oh, I'm eating the
Oh,
paper.
there's fruit inside.
All right.
Do we want to invite Chris up? Anybody? They want to come up and
Yeah, we're
pick
getting
it up?
some inside information. All right, just
Ooh.
missing the champagne. It's fluffy, a little cloudy. Can someone please at least get the person some cake at least? Thank you. Thank you, Twitch Cash. Thank you for loving
Are you
me
talking about
more than
Eric?
anybody up here has. So, all right, does everybody have their cake?
Got my cake.
All righty.
Alrighty.
Should we do it? I want to say happy birthday. Jeff, thank you so much for celebrating this with
Absolutely
us.
my pleasure. Thanks
Yeah,
Thanks,
Farrah,
Jeff.
thank you for coming and your
Yes.
team. Talia, as always.
Thanks,
Talia and I
Eric.
just met in person for the first time this morning, so it was pretty awesome. All right, everybody, fork up. I can't get my fork here. Hang on a sec. There you go.
I just took one.
All right, Mark, get set, go. Right there on TV, I'm talking with my mouth full. My mom would be so mad. With that, we're going to say bye. Again, thank you so much. Thank you to our Vancouver team and our heroes. And we are out. Thank you.
Thank you.
Bye, everyone.